For this video, we'll be demonstrating the functionality of the SmartMqnPump system. I have 3 drives connected, actually 2 drives. The third one on the end here is a little XLE unit. We're just simulating the third drive with that unit. One of the primary features of the SmartMqn system is the ability to alternate which drive is the starting drive for each cycle. This allows us to evenly distribute the wear and tear on the pumps and motors. So the first thing that I'm going to do is just cycle through each drive individually by changing the pressure reading. So we'll drop the pressure down below 60, which is where I had it set from the other day. The first drive kicks on, the pressure comes back up, the frequency follows the pressure to maintain the set point. Now it's at its minimum frequency, which is set at 30 Hertz right now, and after 5 seconds it turns off. That is one complete cycle. Now we're going to drop the pressure again. We'll drop it down below 60 psi, and the next drive in line is the first drive that kicks on now. Pressure comes back up, frequency drops off as we're approaching the set point, and we run for about 5 seconds on the minimum frequency and the drive will shut off. And then finally, that's another complete cycle, and finally we'll drop it down again, and the next pump that will come on will be pump number 3, which is our XLE on the end. We'll bring the frequency back up, and then it will kick off. Actually, I didn't bring it back up soon enough, so our second drive kicked on, that's fine. It will run at its lower frequency. It'll kick off, and now the third drive is running at its lowest frequency and will also kick off. Alright, the next thing I'll show is what happens when the pressure stays low for a longer length of time, and we kind of already saw that at the last part of the first demonstration. So I'll just drop our pressure down low, I'll just leave it low. We can see that our pump 1 started this time where pump 3 was the first pump on last time. Pump 1 runs at its maximum frequency, which right now is set at 66 Hertz. It runs there for 5 seconds, and then the next pump is called for. Now pump 2, if it runs at its maximum frequency for 5 seconds, then it will call for the next pump in line. And now finally we'll say that 3 pumps is doing it now, so we'll start bringing the pressure back up again. We'll see that pump 3's frequency will start to drop as we start coming up. And when as before, when it gets to 30 Hertz and stays there for 5 seconds, it will kick off, and then drive 2 will start kicking on. Will start taking over the process. And as it runs at 30 Hertz, which is the minimum frequency for 5 seconds, it'll kick off, and pump 1 will take over the process. Now I'm going to decrease the frequency here, or the pressure, and we see that the frequency increases on the pump 1. If I bring it back up to the set point, it'll go back down to 30 Hertz again, and then after 5 seconds finally shut off completely. Now there's one more part of the demonstration we want to look at. What happens if a pump drops offline? We'll go ahead and pull the cable on pump number 2. We can see on the screen now that we have a red flashing light on pump 2 indicating that we have a communications loss. Process is still running. We'll drop down the pressure, which will kick on pump 3. Pump 2 was actually the next one in line, but it didn't kick on, so pump 3 did. And pump 1 comes on. We'll raise the pressure back up. Now remember that pump 3 was the first one on in this cycle. Pump 1 kicks off, pump 3 will kick off. Pump 2 is still disconnected, so we're still without pump 2. We'll drop the pressure down again, and we see that now that pump 1 was the first pump on, so it's still alternating even when we have a pump offline. Now if the pump is repaired or for whatever reason comes back online, there's a seamless operation of picking that functionality back up again. Our red light goes off, pump 2 is ready to go now. We drop our pressure down, our pump 3 comes on. I'll go ahead and leave the pressure down until we get all the way back around to pump 2 again. And all of our pumps are running at, let's drop our pressure down really low. All of our pumps are running at 66 Hertz right now. And for this last part of this demonstration, I'm going to kind of trick our system, and I'm going to raise our pressure really fast, which wouldn't happen this fast in real life, but we'll demonstrate what happens if we exceed the max pressure. So the maximum pressure is set at 90 psi, so I'm going to go ahead and raise it all the way up past 90, and we see that all 3 pumps kick off as soon as it reaches that max pressure. That concludes this demonstration of the SmartMqnPump.